The EPR, a new Framatome ANP nuclear reactor, was designed by Framatome and Siemens in close cooperation with Électricité de France and the major German utilities. An economically competitive reactor combining enhanced safety and operating conditions with greater environmental protection, the EPR will provide benefits of the most recent and proven nuclear technologies. Let's start our visit. First, the reactor building. The spent fuel storage building, surrounded by 4 buildings housing the safeguard systems, 2 separate buildings containing emergency-powered diesel generators, and the nuclear auxiliary building, which completes the nuclear island. Finally, the turbine building, which is connected to the grid. The nuclear island rests on a 6-meter thick concrete base mat capable of withstanding the most severe seismic incidents. The reactor core is enclosed within a thick steel vessel protected and supported by a concrete pit. The reactor coolant system is composed of the reactor vessel, 4 loops, each with a primary coolant pump and a steam generator, and the pressurizer. The nuclear reaction in the core generates heat, which is carried by the primary coolant to the steam generators. The reactor coolant system is contained in the reactor building. The EPR features the most effective protection against abnormal events. In the highly unlikely event of core meltdown, a special area with a refractory layer inside the containment would collect and cool any part of the molten core escaping from the reactor vessel. In addition, a large in-containment water storage tank would provide coolant for removing the residual heat of the nuclear fuel after emergency shutdown. This is supplemented by a heat removal spray system to lower temperature and help maintain the mechanical integrity and leak resistance of the containment. Each of the main safety systems of the EPR is comprised of 4 identical subsystems. Each of these subsystems is capable of performing the entire safety function independently in the event of abnormal operating conditions. For added safety, they are housed in 4 separate buildings to avoid simultaneous failure. There are also 4 emergency diesel generators located in 2 separate buildings. A thick outer shell protects the reactor building, 2 of the safeguard buildings, the spent fuel storage building, and the plant control room. This protection makes the EPR particularly resistant to external hazards such as an aircraft crash. The reactor containment building has 2 protective walls, an inner pre-stressed concrete housing and the outer reinforced concrete shell, each 1.3 meters thick. Compared to the most modern nuclear plants in operation, the EPR offers a 10% reduction in electricity generation costs, reduces the risk of accident by a factor of 10 and eliminates any potential risks for the vicinity, provides much improved ease of maintenance and increased availability. To generate the same amount of energy, it requires 17% less uranium and produces 14% less long-lived radioelements. The EPR, our advanced reactor, is ready to meet the ever-increasing global demand for electricity.